Thank you for joining this lesson. We are continuing with our ACK Maseno South Diocese Term 1 exams, Mathematics Paper 1. We are going to discuss section 2 of this wonderful paper. We are going to focus in section 2. In case you did not have a look at section 1, kindly revisit our videos. It is there in our channel. And before we start, I just have to bring to your attention that our consultation number is 07 41 30 43 11. That is our consultation number. In case you want to inquire more, you can reach out via that number. Also, don't forget to subscribe to our channel. Don't forget subscribing to our channel so that you keep getting updates whenever we post them. All the section 1 of this paper was discussed. All these questions were well discussed in our previous class. You can revisit them. So today we are going straight to question number 17 of this paper. A very, very good paper, worth discussion. Let us have a look at question number 17. We are having a look at question number 17 here. Here is the question. It says, students at Maseno Junior School were told to choose 1 out of 3 sports options. We have the basketball, tennis, or swimming. The ratio of students that chose was 2:1, while those who chose tennis and swimming was 3:4. The number of students that chose tennis was 0.5. It should be the number of students who chose tennis was 18. Here we should be having 18. The number of students who chose tennis was 18. Find part 1 of the question. The ratio of the students that chose basketball to the ones that chose tennis. That is what the question is asking. Basketball to tennis. So let us see this. We are being told that basketball to tennis, the ratio was 2:1. That is basketball to tennis. In fact, the question is the ratio of the students that chose basketball to the ones that chose swimming. So tennis to swimming, we have the ratio. So let's first combine this. So this can be easily done this way. If I want the ratio of basketball, maybe to tennis to swimming. I know basketball to tennis is 3:1. The tennis to swimming is 3:4. I have to find a way of making the tennis 4. So I'm going to multiply the upper ratio by 3 and the lower ratio by 1. This will be, I'm going to have 3 by 1 will be 3. Then in the denominator, in the lower ratio, 1 by 3 is 2 and 1 by 4 is 4. So that is 10 basketball to 10 to swimming. When the question is now talking about the ratio of the students that chose basketball to swimming, this is 6:4. 6:4, which simplifies to 3:2. That is the ratio of the students that chose basketball to swimming. Let's have a look at question number 1, 2. The new ratio of students that chose basketball, tennis, or swimming. If 6 students withdrew from the basketball and chose tennis. If 6 students withdrew from the basketball and chose tennis.
That is the question we have. Now I want to look at it this way. First of all, let's get the total ratio. Let's get the total ratio. Let's compute our total ratio here. Compute the total ratio to be given by compute the total ratio to be given by 6 plus 3 plus 4. 6 plus 3 plus 4 giving me a total of that is your total ratio. Now, because here we saw that the number of students that chose tennis was 18, and what's the ratio for tennis here? When you look at tennis would have been 3 over 13, which represents the tennis. So because the number of learners who chose tennis over 18 number. That's what we have to understand. So we are going to compute. These things. So first of all, let's also go the number of students who chose basketball. I want to get now the number of students who chose basketball. So how do we approach that question? For basketball, we have 6 out of 13. So I'm going to ask myself, if 3 out of 13 is equal to 18, what about 6 out of 13? I'm going to have here 6 out of 13 multiplied by 18 divided by 3 out of 13. This is going to give me, let me use your calculator, 6 out of 13 being multiplied by 18, then what you get, you divide it by 3 over 18, so 3 over 13. This gives you 36. So we have 36 learners who chose basketball. 36 learners chose basketball. Also, I want now to get the number of learners who chose swimming. And for us to get the number of learners who chose swimming, we ask ourselves, if 3 out of 13 is equal to 18, what about swimming, which is being represented in this form as 4 over 13? What about 4 over 13? Then it was multiplied. This will now become 4 over 13 being multiplied by 18, then divided by 3 out of 13. This is going to give you a total of, let us do that one together. So you take 4 over 13, you multiply by 18, divide by 3 out of 13. You're going to give these as 24 students. So we get 24 students who chose swimming. We get 24 learners who chose swimming. After getting 24 learners as those who chose swimming, now we have those who chose swimming. Remember this 18, these are the ones who chose swimming previously. I hope up to that particular point, we are all together. It is my hope that up to that particular point, we are all together. After getting that now, we can compute the numerator. Let us now compute the numerator. And now are we going to do this numerator computation? If we did compute the ratio of those students who joined basketball, to tennis ball, to swimming, but this time now we are going to do it in a different way. Remember here we're being told, you can use the new with 6 students to do basketball. So usually we get 36 students with basketball, but 6 will do minus 6 is 2. When you talk about the tennis ball, this we will do from the basketball join the tennis. So tennis we had initially 18. So now we are going to have 18. Then you add the 6 that have joined. But for swimming, they're just going to remain as 24. So 36 minus 30, that will be 36 minus 6. We're going to have this as 30 is to 24. is to 24. That is what we are going to have. Then this you can reduce by dividing 2 by 6. This makes the ratio to be, the ratio of basketball to tennis to swimming becomes 5 is to 4 is to 4. That is how you respond to that particular question. Let us have a look at question number B. The school wishes to ferry all the students that chose swimming to Uganda 25 kilometers away using a van that can carry a maximum of 10 students per trip. The van uses 3 liters of petrol that costs 240 shillings per liter in every 20 kilometers. Calculate Roman 1, the number of trips needed to ferry the students to Ghana. So, we are ferrying how many students? We are only ferrying those students who chose swimming. But how many students chose swimming according to our data? Those who chose swimming were 24. So, remember, when you look at this one, if a van can carry a maximum of 10 students per trip, this means one trip can only carry 10 students. But how many students were there for swimming? We get 24. So to get the number of trips, it will be 1 multiplied by 24 divided by 10. This means this is going to be equal to 2.4 trips. 2.4 trips. But after getting it as 2.4 trips, can we have a half and a quarter trip? No. This you round it up to make it equal to 3 trips. Because if they carry 2 trips, all the learners will not have been carried, meaning the van must come for the third trip. However, even if it will not be full during that third trip, but according to the van, it would have made 3 trips. Roman 2, the amount of money that is required to rent the van. How do we compute the amount of money required to rent the van? How do we calculate the amount of budget required to rent the van? One very big question we have to know here is that what is the distance? The distance is 25 kilometers. So remember, if the distance is 25 kilometers, first of all, I want to get the total distance covered. So the distance one way is 25 kilometers. For it to be further completely, you have to go to and fro. So you multiply this by 2. This is the distance covered for one complete trip. Going is 25 kilometers, coming back to 25 kilometers, that's why I multiplied by 2. But how many trips is the van make? The van makes 3 trips. So you multiply this by 3. This makes your distance to be equivalent to 150 kilometers. So the total distance covered by that van by this is will be 150 kilometers. But now come here, we are saying the van uses 3 liters of petrol. The van uses 3 liters of petrol that costs 2.8 shillings per liter in every 20 kilometers. So let's also compute the fuel use. Let's compute the fuel use. To compute now the fuel use, we are being told that if the van uses 3 liters of petrol for every 20 kilometers. So first of all, let's take the total distance is 150. Let's divide it by 20 to get. Let's divide by 20 to get then this is now the distance multiplied by the cost per liter. So because they are saying here for every 3 liters, 20 kilometers distance will be covered. So you multiply this now by 3, and this will give you 22.5. This will become 22.5 liters. After taking that, now we have to get the cost, or what can be called as the amount. The amount now you take the number of liters per fuel, 22.5, multiplied by the cost per liter, which is 240. When you do that multiplication, you're going to get this being equivalent to 4,815. 4,815 Kenyan shillings. That is how we will have approached that particular question to get it right. Let's make progress to question number 18 of our discussion division document. Question number 18. The equation of a straight line L1 is given as 2x plus 3y is equal to 10. A and B are the x and the y intercepts of line L1, and L is the midpoint of B. Find A and B. The equation of a line L1 is given as this. A and B are the x and the y intercepts of line L1. This is a very, very good equation. Remember, in this case, we have to remember about the intercept. In the x-intercept, the value of y is equal to 0. And when we apply that, so we are going to replace here, this will be now 2x plus 3y, but now y is going to be 0, so this will be 12. 3 times 0 is 0, so this will be 2x is equal to 12, meaning x will be equivalent to 6. The moment you give the value of x as 6, remember that A and B are the intercepts, so that means 5 and B, so it means the value of A will be equivalent to, the value of A will be equivalent to 6. Then for B, B should be the y intercept, and the being told here that we need to know that in the y intercept, the value of x is equal to 0. When you substitute, this will be 2 into 0 plus 3y is equal to 12. So this means 3y is equal to 12, meaning y should be equal to 4. And if y is equal to 4, that y is equal to b. This means that the value of b is also equal to 4 in that particular question. So after that now, because the question wants to find and b, these are the x and y differences, so we are going to say our a will be 6, 0, because it is the x intercept is 6, 0. Then our b will be 0, 4, 4 for our b in that particular question. So that is how such a question has to be approached. That is how such a question has to be approached. Roman 2, the coordinates of M. What are they saying? M is the midpoint of AB. M is the midpoint of AB. How do you get the midpoint? So when you are supposed to get M, remember the midpoint is given as x1 plus x2 divided by 2, then y1 plus y2 divided by 2. Abiding by that rule, we are going to compute M being equivalent to our M here will be x1, that will be 6, plus 0 divided by 2, comma, then 0 plus 4 divided by 2. So 6 plus 0 divided by 2, that will be 3, 2. But now because we want to be coordinate form, so we are going to have our answer as M into 3, 2. M into 3, 2. That is the coordinate of M. And that's how you can put your answer. Very, very basic mathematics, ladies and gentlemen. Let's make now progress to the next part, part B. Another line L2 is perpendicular to L1 at M. Point P is on the line L2, and the equation of AP is given as 7x minus 9y plus 36 is equivalent to 0. Find Roman 1, the equation of L2 in the form y is equal to mx plus c. and P are constant. Look at that. We are seeing another ray L2 is perpendicular to L1 at M. The point P is on line L2 and the equation of AP is given as 7x minus 9y plus 36 is equivalent to 0. Find the equation of L2 in the form of y is equal to mx plus 6. The first thing you should bear in mind, let us have a look at the equation of line L1. The equation of our line L1 was 2x plus 3y is equal to 12. We get 2x, we get here 2x plus 3y being equivalent to 12. I want to write this equation in the form of y is equal to mx plus 6, where I'm going to have now 3y is equivalent to negative 2x plus 12. That means y, when I divide 2 by 3, y is equal to negative 2 over 3x plus 4. So that means the gradient of line 1 was negative 2 over 3. That is what you need to understand. That the gradient of line L1 is negative 2 over 3. But because now L2 is perpendicular to L1, you must have learned that the gradient of line 1 times the gradient of line 2 will be equal to negative 1. That is for perpendicular lines, the product of their gradients is equivalent to negative 1. Applying the same, I'm now going to have here negative 2 over 3 L2 is equivalent to negative 1 GL2. So that means the gradient now of line 2 will be equivalent to 3 over 2. The gradient of line 2 in this particular question is 3 over 2. After now we found the gradient of line 2, we are being told that this line 2 first is perpendicular to line 1 at point M. At point M. Remember we have the point M, yes, point M being equal to 3, 2, and the gradient 2 is 3 over 2. So this is sufficient enough for us to form the equation of line L2. How do you form the equation of line L2? We are going to have this as y minus 2 all over x minus 3 being equivalent to 3 over 2. Being equivalent to 3 over 2. Then you could multiply, you are going to get 2 into y minus 2 being equivalent to 3 into x minus 3. Then when you look at this, you open the bracket, you are going to have here 2y minus 4 being equivalent to 3x minus 9. Then we need to write it in the form of y equals to mx plus 6. So this means we are going to have this as 2y being equivalent to 3x minus 4 now, so minus 9 plus 4. We have it as minus 9 plus 4. So this becomes 2y is equivalent to 3x minus 5. 2y is equal to 3x minus 5. But are we using this in that particular way? No. You can't use it that way because it is given a form to use it. So this will now become y, when you divide through by 2, you get y is equivalent to 3 over 2x minus 5 over 2. Minus 5 over 2. But always use your answers in a simplified way, where we are going to have our final answer is y is equal to 1.5x minus 2.5. That is now in the form of y is equal to mx plus c. That is how you can use that particular answer. Roman 2, the coordinates of p. We are now supposed to get the coordinates of p. The coordinates of p. When you look at this, we are being told that point P is on line L2 and the equation of AP is given as this. So we have the equation of AP and we have the equation of line 2. So we need to solve the two equations simultaneously. And the point of intersection will give you the coordinates of line 2. So here what we are going to do with this particular question, we are going to solve this equation simultaneously. Remember, how do we solve this simultaneously? The equation of AP is 7x minus 9y. We have here 7x minus 9y. So sorry, I'm writing on the wrong place. So here. We have 7x minus 9y. We are having here 7x minus 9y. 7x minus 9y plus 36 is equal to 0. Plus 36 is equal to 0. That is the equation of the line AP. But we have the equation of line 2, which we found as y is equal to 3 over 2x minus 5 over 2. We made y being equal to 3 over 2. We are having here 3 over 2x. We are having here 3 over 2x minus 5 over 2. I'm going to use substitution, and I'm going to substitute equation 1 onto equation 2. I'm going to substitute 1 onto the equation. Where there is y, I'm going to put the y value. So I'm going to have 7x minus 9. Instead of saying 9y, now I replace y with the value, which is that is now going to be 3 over 2x minus 5 over 2. Then now plus 36. This is still equivalent to 0. Let us open the bracket. This will be 7x. Then now I'm having negative 9 multiplied by 3 over 2. This is going to give you negative 13.5. This will be now negative 13.5. Then you have negative 9 being multiplied by negative 5 over 2. Negative 9 being multiplied by negative 5 over 2. This is going to give you 22.5, positive 22.5. This was x, then this is plus 22.5. Then now my plus 36 here is equivalent to 0. Then 7 minus 13.7x minus 13.5x, you will get negative 6.5x. Then now plus 22.5 plus 36, that becomes 58.5, being equivalent to 0. When you reach that particular point, what are we going to do here? At this particular juncture, we are now going to collect the like terms and we're going to say negative 6.5x is equivalent to negative 58.5. Dividing through by negative 6.5, you're going to get the value of x as, when we do the division, get the value of x as 9. X is 9. After this x is 9, we can get the value of y because we know that y is given as 3 over 2, x is now 9, minus 5 over 2. So this means y will be given as 3 over 2, 3 over 2, being multiplied by 9 is 13.5 minus 2.5. So when you have 13.5 minus 2.5, this gives you 11. Here's the value for y. Now, what is the question asking? The question is focused on getting the coordinates of P. How are we going to put our answer? To get now the coordinates of P will be given. P will now be given as 9, 11. 9, 11. That is how you respond to that particular question. Let's have a look at question number 19. Part A. Given that A 2, 1, X 3, and B 4, 2, 3, 2, and determine that the determinant of AB is 16, find X. First, they're talking about the determinant of AB. Let's get matrix AB. First of all, let's compute AB. Matrix AB is given by matrix A, which is 2, 1, X 3, multiplied by matrix B, which is 4, 2, 3, 2. I hope you remember how we multiply matrices. Row times column. 2 times 4 plus x times 2. This will become 8 plus 2x. 8 plus 2x. Then 2 times 3 plus x times 2. This will become 6 plus 2x here. 6 plus 2x. 1 times 4 plus 3 times 2. That will become 4 plus 2, which is equivalent to 10. Then 1 times 3 plus 3 times 2, that is like 1 plus 6 is 9. So 3 plus 6 is equivalent to 9. So this matrix we form here is the matrix AB. That is the matrix AB. Now after finding the matrix AB, what is our next step according to the equation? Our next step according to the equation is now to get the determinant of AB. We are now supposed to focus on getting the determinant of AB. How do you compute the determinant? The determinant of the matrix is given by the product of elements in the main diagonal. That is 9 into 8 plus 2x. That's the product of elements in the main diagonal. You minus the product of elements in the minor diagonal. 10 into 6 plus 2x. This should give you the determinant. But now already we've been told that the determinant is 16. So this will give you 16. So let's try and work it out. Now this is like 16 is equivalent to. This is 9 times 8 is 72. So the rate of this is 72. 9 times 2x, that is plus 18x. That way, I hope I'm very, very systematic, such that learners are getting exactly what I'm saying. Minus, this one will now become, this will be 60. In fact, yes, 60 plus 20x. That way. So when we are at that particular juncture, we are progressing very, very well. There is nothing to worry about. Keep subscribing, liking, and sharing our videos with your other friends. So this is now going to become 16. Being equivalent to, let's open out the bracket. This will be 72. We are going to have 72 plus 18x. Then negative 60. Look at how this negative is going to affect here. Negative 60, then also is going to be negative 28. I hope you see how the negative has impacted that bracket. So collect the like terms, we're going to have 16 is equal to 72 minus 60, that means 12. 18x minus 20x, that will be negative 2x. Collect the like terms again. I'm going to have this as 16 minus 12. 16 minus 12 being equivalent to negative 2x. That means 4 is equivalent to negative 2x. Dividing through by negative 2, we are going to get 4 over negative 2 being equivalent to x. Because the question has the value of x, it means x is going to be equivalent to negative 2. X is going to be equivalent to negative 2 for that particular question. Let us look at part B of the question. Part B of the very question. We are being told in part B that Maseno School bought 40 dozens of a single rule book and 15 dozens of square ruled exercise books for a total of 81,900 shillings from bookshop A. When the school is ordered for 35 more dozens of single rule books and 20 more dozens of square rule exercise books from the same shop, they paid 78,660 shillings after being allowed a 5% discount. Taking X to represent the number of dozens of single rule books and Y to represent the number of dozens of the square rule exercise books, find part one of the question, the two equations representing the above information. The two equations representing the above information. Remember, from the single rule book, it is x. So this is going to be 40 times x to make it 40x. We are going to have here 40x plus 15y. This was costing 81,900. 81,900 shillings. When the school reordered for 35 more dozens of single rule books, so when you add 35 let us see. When the school reordered 35 more dozens, when the school reordered 35 more dozens of single exercise books, meaning when it reordered 35, so that will be 35x and 20 more dozens of square rule books plus 20y. They paid 78,660 after being allowed a 5% discount. What does it mean? This means this was not the real price that they should have paid. But now let's get the real price of this 35 dozens of a single rule book and 20 dozens of the square rule book. And now together, if this is after being given a 5% discount, meaning the 78 is 60 is equivalent to the 95% of the original price. What was the original price of those books? It was multiplied. This will become 78 you multiply by 100 and you divide it by 95. This is going to be this is like saying 100 over 95 being multiplied by 78,660 to give you 82,800. I hope that point is well communicated. So this is the price that we were to pay. So that is 82,800. So those are the two simultaneous equations that we can form from the information given above. Those are the two simultaneous equations that we can form from the information given above. But rather we can simplify them. I prefer we simplify them. When you simplify the first equation by dividing through by 5, 5 divided by 40 divided by 5 is 8, this will be 8x plus 15y divided by 5, that will be 3y, being equivalent to 81,900 divided by 5, that will become 16,380. We can even simplify the second equation by dividing through by 5. 35x divided by 5, that will become 7x. 20y divided by 5, that will be plus 4y, being equivalent to 82,800 being divided by 5 to get 16,560. We are done with that particular point. However, it's not the math to simplify, but you can just simplify to make your work easier and within the next step according to the question. The cost of each single rule book and each square rule book before any discount is allowed using the matrix method. So let us now use the matrix method. They are very, very particular here that you have to use the matrix method. So first of all, let's form a matrix equation. Because what we form there are simultaneous linear equations. So the matrix equation, I'm going to use the simplified value. I'm now going to have 8374 xy. This is what is called a matrix equation. This is 16380, then 16560. That is a matrix equation. After forming the matrix equation, let's get the determinant part of the matrix. So the determinant will be 8 being multiplied by 4 minus 3 being multiplied by 7. So 8 and 4, that is 32 minus 21, which is going to be equivalent to 11. So our determinant here is 11. After getting 11 as our determinant, ladies and gentlemen, now let's get the inverse of the matrix. And how do you get the inverse? It is going to be 1 over the determinant, which is now 11. You multiply by the elements in the main diagonal getting a change. You're going to have 4 here, then 8 at the bottom. Then the minor diagonal, the sign changes, negative 3, negative 7. That way, which when you work out further, you're going to get this as 4 over 11, negative 7 over 11, negative 3 over 11, 8 over 11. That is the inverse of that particular matrix. After getting the inverse of the matrix, the next step will be, we are going to pre-multiply the inverse of the matrix to either side of the equal sign. So I'm going to have here 4 over 11, negative 7 over 11, then negative 3 over 11, 8 over 11. This one I'm multiplying to 8734 xy being equal to, even to the right hand side, if you multiply, that is 4 over 11, negative 7 over 11, negative 3 over 11, 8 over 11. This one here, you can multiply it to 16,380, then 16,560. 16,560, this is 16,560. That way. We are progressing well. Keep subscribing, sharing the link to your other friends so that they might also enjoy this session. That is there. Now, when you multiply the inverse of the matrix from the matrix itself, we are going to get an identity matrix in the form of 1001, 1001, now times xy. This will give you, how do you perform multiplication? It is normally row times column. So I'm going to have here 4 over 11 being multiplied by 16 repeated, plus negative 3 over 11 being multiplied by 16 by 60. This is going to give you 1440. We are going to have here 1440. Then on the lower part, we are going to have negative 7 over 11, negative 7 over 11 being multiplied by 16 to the 18, 16 to the 18 plus this will become now 8 over 11 being multiplied by 16 by 60. And this is going to give you 1620. That way, 1620. With the matter identity of the matrix and the matrix xy, we are just going to get the matrix xy now, being now equivalent to 1440, then 1620. That's what we are going to get. After getting that particular matrix, the question, what was the question? The cost of each single rule exercise book and each square rule exercise book before remember a dozen contains 12 items. A dozen contains 12 items. Let's get now the cost of so this means this 1440 is the cost of 12 this 1440 is the cost of 12 single rule books. Let me get now one single book. One single rule book would now cost 1440 divided by 12. This is gonna become the cost of one single rule book is 120 shillings. Then also let's get one square. Let's get the cost of one square rule book. The cost of one square rule book to take 1620. You divide again by 12 because that was for the dozen, and a dozen contains 12 items. This gives you, this is going to give you 135 shillings. That is how you're going to respond to that particular beautiful question, ladies and gentlemen. Let's have a look at question 20. Thank you for watching. I'm very happy to have you in this matter. A bucket is in the shape of a frustum of a coil. The base radius of the bucket is 15 centimeters and it is filled with water to a height of 30 centimeters. The radius of the water level in the bucket is 20 centimeters. Taking 5 to 0.142 and then the quantity of water in the bucket in liters. The atom of it being in the shape of a frustum, so the best is to attempt it by sketching first. I'm going to have my sketch. That is my bucket. The base radius is 15. This one is 15. So it is filled with water to a height of 30 centimeters. So let's assume it has water up to this particular height. So this is water. The vertical height from here to this point is 30. The radius of the water level in the bucket is 20. This radius is 20. Taking 5 to this, there is a volume of water here. So I'm going to drop this one to this. To join and get the part that is dropped off. So that means I'm going to have a figure like this. If you are ready to observe, this is 20. This is 16. From here to here, 30 from here to here, we not can call it K. So first of all, let's compute that height of the cone part at the platform, and we have 15 over 20 being equivalent to K over 30 plus K. So that means 20K will be equal to 15 into 30 plus K. So this is 20K is equivalent to 15 times 30, that will be 450 plus 15K. Collecting like terms, so let's get 5K because 20K minus 15 will be 5K. This will be equivalent to 450. And that means that your height K will be 90 centimeters. After getting that particular height to 90 centimeters, we can now calculate the volume. We can go ahead and calculate the volume in this particular question, because you know that the volume will be given by volume of a cone, the volume of a bigger cone minus the volume of a smaller cone, which is given by a plus pi r squared h minus a plus pi r squared h. In this context, we are going to have this as a plus times 5 to 3.142 times the bigger here, which is 20 squared, times the total height. The total height now will be 30 plus 90, give you 120. You minus a part being multiplied by 3.142 by the smaller area, which is now 15 squared, by the smaller height given as 90. So let us work it out. So this will be now, when you take a part times 3.142 times 20 squared times 120, this is going to give you, when you do the multiplication well, 50,000. We have here 50,272. Then you subtract a third times 3.142 times the radius, which is now 15 squared, times the height, which is now 90. This is going to give you 21,000. This is going to give you 21,208.5. Then when you perform the subtraction, you're going to get 29,063.5. This is cubic centimeter. But now because they want it in liters, you know that 1 liter is equivalent to 1,000 cubic centimeters. What about this answer is gotten? Meaning we have to divide this by 1,000. And when you divide it by 1,000, you're going to get 29.0635 liters. 29.0635 liters. That becomes your answer from Roman 1 of the wonderful question. Let us now look at Roman 2. The surface area of the bucket in contact with the water. The surface area of the bucket in contact with the water. So to get that surface area of the bucket in contact with the water, we are going to calculate the plant height. We have this, if this is 120 and this was 20, I can get the big L. 90 degrees. So the big slant height L will be given by 90, the root of 120 squared plus 20 squared. So this is going to give you, when you look at it, 120 squared plus 20 squared, then you square root, you're going to get 121.66, 121.66 centimeters. That is the biggest slant height. The minor slant height that is attributed by this, if this is 15, this is 90, this L. The minor slant height, or rather smaller one, is the square root of 15 squared plus 90 squared. When I take 15 squared plus 90 squared, then use square root, I get 91.24. 91.24 centimeters. We are done up to that particular point. Now, because we just want the curve surface, they want the surface area in contact, we are going to be very, very soon. First, I can start by calculating anything. I can calculate the bottom circle, because when you look at the question, the bottom water is equal with the bottom. So the bottom circle, maybe calculate the bottom part, and because it is circular, it's pi r squared is area. So we have to use here 3.14 to multiply by 15 squared. When you execute that, 3.142 times 15 squared, that gives you 706.95 square meters, 706.95 square meters. That is for the bottom part. After getting the bottom part, we can also now compute the curved surface area. The curved surface area. And to compute the curved surface area, the curved surface area of a cone is given by pi rl minus pi rl, given the curved surface area. So the pi will be 3.142 as per the question, multiplied by the bigger radius, which is 20, multiplied by the bigger L, which are found in 121.60. Now you subtract 3.142 multiplied by the smaller r, which is 15, multiplied by the smaller L, which is 91.24. So this will become, when you take 3.142 by 20 by 121.60, you get 76.45 76.1144. Then you minus, when you take 3.142 by 15 by 91.24, you are going to get 4300.1412. Now let's get the difference between the two. The difference we are simply subtracting. Make sure you use your calculator well. When you subtract, you are going to get that is 344. That is 344.9732 square meters, square centimeters. Now to get the total surface area, compute now the total surface area. We take the area of the bottom circular part 706.95 plus the area of the curved part recorded in the water 3344. We are having 3344.9732. When you sum this, let us sum using our calculator. When you sum using your calculator, you're going to get 4051.92 raised to square centimeters. That is how you work out that part. Let's now look at part B, where we are going to specify the volume of the water that is added in the bucket will give a 10 centimeter rise in the water level. 10 centimeter rise in the water level. So what that means, what it means, we're going to have a diagram like this. I want us to give a sketch. So this one initially it was at 15. This was 90. And now this was 30, but we give a 10% rise in height. That means that this one will be 10 plus that is 4. Now I want to get this radius here. And to get that particular radius, we are going to say 15 over r is going to be equivalent to 15 suppose a height of 90 over r is suppose a total height of 90 plus 40, giving me a total height of 130. Then you cross multiply this will become 90r is equal to 15 multiplied by 130. So r will be given by 15 multiplied by 130 divided by 90. Then it means that our radius r, when you do that, what are you going to get? Let us be very clear. This is going to give you 21 and 2/3. 2 over 3. That is the radius at that particular point. After now getting that as the radius, ladies and gentlemen, we can now do the calculation. Because it seems now we have to get out the volume of the water that will be added to give a 10% increase. It's going to be very simple. Let me make it give a sketch. So it means we are going to have such a diagram. We had our bucket here. So initially the water level is here. Now the water level is at some point here. Maybe let me extend. Let me say that it will still going. It will be here. So from here to here, this side is now 10. And the radius at this particular point is now 21.57. The radius here equals at 20. So now we want to get this volume that has been added here. So to get that one, we are going to calculate using this approach. This is the approach I want to take in our particular question. Remember that volume is given by a plus 5r squared h minus a plus 5r squared h. So when you are here, this is going to be a plus times 5 which is 3.142 times the bigger radius which we now found to be 21 and a third, that's like saying 65 over 3. Times 65 over 3 because it's squared. And the total height is found down to 130. that way minus plus being multiplied by 3.142 being multiplied by r squared, which is now intelligent to the 20. So that is 20 squared. Then right at that particular point it is 120. It was 120. That way. So let us use our calculators once again. When you take a third times 3.142 times 65 over 3 squared times 65 over 3. So 65 over 3 squared times 130. This will give you 63,870. What is it giving? Let me just a moment. Let me check. A third times 3.142 times 65 over 3 squared multiplied by 130. You should be getting 63. You should be getting 63,916.43. Then you make this will give you 50,272. This is going to give you 13,644.43 cubic centimeters. That is the volume that we added to give that as an increase. That is how you approach that particular question. That's how you approach that particular question. Let's make progress and consider now the question 21. That the mass scored by 40 students in a test were recorded in the table below. Starting with 3 and using a class interval of 4, develop a frequency distribution table. We are supposed to develop a frequency distribution table. Let us see where am I going to work it from. Let's see. I'm trying to see if I can see it somewhere. This is something. Let me see it at this particular point. We are going to have a column for class. Rather, let me just start it here. We are going to have a column for class. I will not use the timing. I will not use the column for the timing, but I'll have a column for frequency. So let us see what is required of us. So let's start with the classes, starting from age 3. Meaning we are going to have the first class is 3 to 6. Next one we have 4, 3 to 6, 7 to 10, 11 to 14, 15 to 18, 19 to 20, 19 to 21, 22, 23 to 26, 27 to 30, 27 to 30 here. Let's do the frequency. 3 to 6, 3 to 6 we have 1. Numbers ranging from 6 to 6 to no, this one no. 3 to 6, 3 to 6, 2, yes. So the frequency is 2, 7 to 10, 7 to 10, relative, 7 to 10. When you look at this 7 to 10, well, 1, 2, 3, 4, 5. We have 5. Under 7 to 10, we are having 5. 11 to 14, 11 to 14. I will tackle those ones, 11 to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are 10. 15 to 18, let me use a blue pen. 15 to 18. Those ones I can put an X. 15 to 18. And 1. Five, 6, 7, 8, 9, 10, 11. So they are 11. I will pass down the door. Oh, there is one I've left. There is one I've left. So 11 where this one here, 12. Be very thin. So this means 15 to 18 is their 20 number. Then let us see 19 to 22. We have now 19 to 22. Those ones I can use. Let me use. I can use a green highlighter. 19 to 22. We have 1, 2, 3, 4, 5, 6, 19 to 22, 7. So those are 7 in number. These are 7 in number. 26 to 36. So 23 to 36. 23 to 26. 23 to 26. I allow I use a black to this time round. 23 to 26. I can also dash them. 23 to 26. We have 1, 2, 3. Yes, there are 3 numbers. So we have there is 3. Then whatever is left is falls under 27 to 30. We have 1. We are calling it only. Do you have any other? I think all others have been marked, so it's only 1. So those are their frequencies. Now, from this we can now proceed because that we are done with quite the most difficult test to many learners in using their eyes going there. But I've done it for you. Now we can progress. We can now progress very, very easily. We can now progress very easily here. Now progress very, very easily. So after that particular point, remember we are making a frequency distribution of data. We are done with that. So, as we proceed, what I want us again to calculate is maybe we can use the last one. That's just a frequency distribution table. Because it's 2 marks, the first mark is for getting the class correct to get the first mark. Then distributing of frequencies will get another mark. That is sufficient enough to earn the 2 marks. When you talk about a frequency distribution table, this is a table that shows how frequencies are being distributed among all the classes. Now let's make progress. From a bit of part detail, using the frequency distribution table is about calculating the mean mark. Knowledge and formula is very important because you know that mean is x bar is normally given by summation of fx over the summation of f. That means we need a column here in x. Let's deal with that column. X is simply the midpoint. 3 plus 6 divided by 2. That will be 4.5. 7 plus 10 divided by 2. That is 8.5. This will be 12.5. 16.5. 20.5. 24.5. 27. So this will be 8.5. 8.5. Then the moment we have done that, x, we can calculate a column. Maybe before that, we should have gotten the summation of f here. When you add that f column is the summation of 4. Now we go and calculate a column called fx. Fx means f times x. So 2 times 4.5. This is going to be 9. 5 times 8.5, that is 42.5. 10 times 12.5, that is 1.5. 12 times 16.5, that is when you take 12, the method of 16.5 is to, sorry, I'm speaking wrongly. You get 198. 7 times 20.5, that gives you 143.5. Then 3 times 24.5, that is 3.5. Then 1 times 28.5, that gives you 28.5. Let us find the summation of fx here. This summation upon adding the 2 so that will be sufficient enough to help us answer the mean part. Because we know that mean is given by summation of fx over summation of f. This is now going to become 620 divided by 40. This gives you 15.5. As the answer to that particular question. Part C, we are being told to get the median mark. First of all, before we get the median mark, let's get the median position. Median position. So the median position will be n over 2. So that is 40 divided by 2 to give you 28. 28th position. After getting to the 20th position, there is a column we need earlier called the t-test column. Let's add here the t-test column. The first value should be the same as that of frequency, which is 2. Then the next value should take 2 plus 5 gives 7. 7 plus 10 is 17. 17 plus 12 is 29. 29 plus 7 is 36. That 6 plus 3 you get that 9. That 9 plus 1 you get 40. So here you are going now to see Where does 20 lie? Where does 20 lie here? 20 lies in 29 under here. So this becomes your median class. This one here becomes your median class. After that, now we are going to do so the median class here, if you are at the median class, for example, if in an exam you are asked about the median class, your answer would have been 15 to 18. That is the median class, 15 to 18. But now let's make progress and on the multiplication. Because now they want the median, we are going to apply the median formula, whereby we know that median is given as L plus N over 2 minus EF over F times I. So this will be, the lower class limit now will become 14.5 plus N over 2 is 40 divided by 2, making it be 20, minus the previous cumulative frequency, or as the cumulative frequency about the median class, which is 17 in this case, over the frequency of that median class, the frequency is 12, times the class interval of 4. So this will become 14.5 plus, let us solve this, 20 minus 17, that is 3. So we have 3 over 2 being multiplied by 4 to make it 6. Now 14.5 plus 6, this is going to give you 20.5. That will be your median mark. 20.5 is going to be our median mark. 20.5 is going to be our median mark. I hope. So what is the frequency? The frequency here was 12. I divided by 2 instead of by 12, which is wrong. So this should be over 12. So that is 20 minus 17 is 3. So we have now 3 over 12 multiplied by 4 to give you 1. Apologies for that. To give you 1. So this is 1 here. So we have 14.5 plus 5. That means, so 14.5 plus 1. This means median 15.5. So you can see the median is 15.5. 15.5. But if this frequency polygon to represent information about. We are now supposed to draw a frequency polygon to have the information about the equation. So how are we going to start the drawing? When you talk about the frequency polygon on the y-axis, we are going to have the frequency column because the y-axis will be frequency. Literally, there's something I want to understand. When you talk about a frequency polygon, this is simply a polygon of frequency. This is one thing that learners have to understand. Meaning, in the y-axis it must be frequency always, not frequency density. So that is on the y-axis here we have the frequency. Then on the x-axis we are going to have the midpoint of the class boundary. The midpoint. Let's make progress. So let me look at the frequency. My frequency go as far as also as 12. So I can go with the interval of 2. Can have the 0, 2, 4, 6, 10, 12, maybe 14, and 16. What about the midpoint of the class? So the best I do here, let me look at the classes. Start from 7, so it starts from 2, from 3 to 6, that will be 2.5, 2.5, so you start 2.5. I'm going to have here this 0 here, let me make it here, let me stretch it around, the 0 of here, this will start with 2.5, because it goes up to the maximum, the highest class is 30.5, or what is given the volume, and then move to 30.5. So starting with 2.5, then 6.5, 7.5, 6, 10, 14. So if I start with 2, 6, 10, 14, 6, 10, 14, 20, 24, 25, yeah, it's correct. So this will be 6.5, 10.5, 14.5, 17.5. After 14, after 14.5, we are moving with 15, 16, this is 15.5, 22.5, 26.5, 30.5, maybe we get another one is like 4.5, but no need. So the midpoint, remember, so here 3 to 6 is equal to 2. The midpoint of this class here is equal to 2. So the midpoint is here, and here. Then between 6 to 10, we have 5 applications of 5. Then between here, we also 5. So let's do 5. That is the 5. I hope you can see when in between the class interval, we locate the 5. And the start in the next one, so then you can also locate, but in between, that is the 10. After the 10, the next frequency should be 12. The next frequency should be 12. I'm locating at the midpoint of my class interval. After 12, the next class interval will be 7. 7. 7. 7 is here. 7 is here. Then located. Then after 7, the next frequency should be 3. The next frequency should be 3. Then in between 2 and 4. Like that, that is 3 well located. But let's see. Have we done it well? No. Why? Because when you are drawing a new program, there is no frequency polygon. There is one major thing I forgot. You have to we were supposed to introduce another class before. We were supposed to introduce a class before, so that we normally join the frequency polygon to the endpoint. I am sorry I have forgotten the name about that, but we have to, because whenever you're drawing a frequency polygon, you have to introduce a class before and a class after. It's a math. It is always a math that introduces the class before and the class after whenever you're drawing a frequency polygon. I get only that point, which is very, very important. It is very, very important that you must always introduce the class before and the class after. So let us make sure we introduce the class before. So when you look at here, let's again display the circuit. We have 3 to 6, 7 to 10. Then the next one will be 0 to 2. So we are going to have that before. We can have here 0. Then this class will be 0 to 2. I want it to be very, very clear that particular concept.
So as we are drawing this frequency polygon, remember that a frequency polygon, as I had said, it's a polygon of frequencies. So what we are going to do, on the x-axis, we are going to choose a certain class. I can pick a class in a class interval starting with 0.5. This I can have this as 4.5. Then as I keep progressing, this will be 7.5. Let me see. I want to move because the class interval should be, the scale should be uniform. That will be 4.5, 8.5, that way. So this will be 8.5. This will be 12.5, 16.5, 20.5, 24.5, 28.5, 32.5. That is what we are having. Then we can see now, remember that we plot the frequency against the midpoint of the class boundaries. So 4.2, 4.5. Let us see at 4.5, the frequency is 2. It's here. At the next midpoint of 8.5, the class interval is 5. At 8.5 here, the class interval is 5. So 5 is somewhere between 4 and 6. There. At the midpoint, which is at 12.5, the frequency is 10. 12.5, then 10 is here. Let me see. Yes. At 19.8, at 16.5, the frequency is 12. 16.5, 12. 16.5 is here. 12 is here. At 20.5, the frequency is 7. 20.5. 7 is between 6 and 8. Between 6 and 8, we have 7. Then at 24.5, the frequency is 3. 24.5. 3 is between 2 and 4. Then at 28.5, the frequency is 1. 28.5 here. The frequency is 1. Then we join these points using a ruler because they should be straight lines. Let's join using a ruler. Let me use a blue ink and this particular juncture. Make sure they are very straight lines. joined using a ruler. Very straight lines joined using a ruler. We are joining them now using a ruler. We are joining them using a ruler that way. When you look at this, our frequency polygon is hanging, and you can never leave your frequency polygon hanging. Therefore, we are going to anchor it to the midpoints of the class we introduced before and the class we introduced after. So this one here, you join it to we anchor it to the midpoint of the class we introduced before. So I join it at that particular point. Then also this at this end, we join it to the midpoint of the class we introduced after this particular point. So that is how now a frequency polygon for such like a question is developed. And that marks the end of that question. Let us have a look at question number 22. Remember, our consultation number still is 07, 41, 30, 43, and 11. Don't forget to subscribe to our channel and share this link to your other friends so that they may also benefit from these free classes. Let us have a discussion on question number 22. That the curve with the equation y is equal to x squared minus 5x plus 7 cuts the curve with the equation y is equal to a half x squared minus 5 over 2x plus 7 at point A and B as shown below. The region R is bounded by the two curves. Part A of the equation, find the coordinates of B. When you look at B, that is the intersectory point between the two curves. That is the intersectory point between the two curves. And there is one particular thing that I want my learners to understand. At the intersectory point, I want you to understand that at intersectory point, comma, y values are always the same. That means because when you look at B is the point of intersection, then the y values of both the equations are the same. So meaning I can equate the two equations and get it. So I take the first equation, its y value will be now x squared minus 5x plus 7. I have here x squared minus 5x plus 7. I equate it with the next one, which is a half x squared minus 5x. I have here a half x squared minus 5 over 2x. We are minusing 5 over 2x, then we add the 7. Let us have this sorted. When we do this, we are going to have something like this. I want you to pay much attention. So let's try and collect the like terms. I'm going to have here x squared minus a half x minus 5x plus 5 over 2x plus 7 minus 7 is equal to 0. So when you are there, this is now going to be x squared minus a half x squared. This will become a half x squared. Then we have minus 5x plus 5 over 2x. So we have negative 5x plus 5 over 2x. That becomes negative 5 over 2. We have here negative 5 over 2x. Then this one here, plus 7 minus 7 becomes a 0. So this one is equals to 0. We can opt to remove the decimal point, sorry, the denominators there. we can opt to remove the denominators. So by multiplying each term here by 2, so this will become x squared minus 5x is equivalent to 0. We can factor out the common factor x. I'll be left with now x minus 5 is equal to 0. That way. This means in the first case, x can be equated to 0. In the next case, I have x minus 5 is equal to 0. That means x will be equal to 5. So we have two values of x. X can be 0 or x can be positive 5. So when you have x being equal to 0 or 5, when you look at this, the x at point A is 0, but at point B now it is this 5. Therefore, it means that the x coordinate of B is equivalent to 5. The x coordinate of B is equivalent to 5. Part B, estimate the area of the region using the trapezium with 5 strips. We need to estimate the area of the region using a trapezium with 5 strips. So from 0 to 5. So I'm going to have it this way. The first thing here, I'll have the first equation y. Let me see if the space will be sufficient. I'll have the first equation y, which was x squared minus 5x plus 7. I'll also have the next equation y. I can call that one y1. I can have my equation y2. That is I have x squared minus 5 over 2x plus 7. Then I'm arranging my work because I want you to understand exactly what is done in this question. Then we have the x. X moves from 0 to 5. So we have here 0, 1, 2, 3, 4, and 5. In that manner. Let us see what is required of us. Let us see what is required of us. So here we go. When x is 0, what will be the value of y? 0 squared minus 5x plus 7. This will be 7. When x is 1, y will be 3. When x is 2, y will be 1. We are substituting. When x is 3, y will be 1 again. When x is 4, y will be 3. When x is 5, y will be 7. We go to the next one, the lower equation. When x is 0, y will be 7. When x is 1, y will be 5. When x is 2, this will be a half into 2 squared minus 5 over 2 into 2 plus 7, making the value of y to be equivalent to 4. When x is 3, y is 4. When x is 4, y is 5. And when x is 5, y is 7. Now let's get the difference in the y values now, which I can call now y1. I can talk about y2 minus y1. y2 minus y1. Why am I talking of it that way? Look at this. We had two equations. The curve cuts the curve with this equation cuts the curve with this at point A and B as shown. So we are having two equations here. So the difference, remember when you look at this, they want this region R, meaning that it is the region bounded by the curve, the upper curve and the lower curve. So the difference in their equations will give you the equation that represents the area in between them. So that's why I'm subtracting. So it is y2 minus y1. So 7 minus 7 is 0. 5 minus 3 is going to be 2. 4 minus 1 is 3. 4 minus 1 is 3. 5 minus 3 is 2. 7 minus 7 is a 0. We are having that one that way. Now we can go and calculate using now the trapezium rule. How are we going to do this computation? You know that area by trapezium rule is given by a half h into y naught plus yn, then now plus 2 into y1 plus y2 plus y3 plus y4. That way. That is the formula using the trapezium rule. How do you get the h? H is given by xn minus x naught divided by 2. So this is, when you look at it, they were talking of it well. So not divided by 2, by divided by the number of strips. The number, we have to divide this by the number of strips here. Xn minus x naught divided by the number of strips. So this will be 5 minus 0 divided by 5, making the value of h to be 1. H is now 1. So this will be now a half multiplied by 1 into y naught, which is 0, plus yn, which is 0, plus 2 into the remaining y's, which is in this case 2, plus 3, plus 3, plus 2. So a half times 1, that is going to be a half, into 0 plus 0 is 0, 2 plus 3 is 5, plus 3 is 8, plus 2 is 10, times 2 is 20. So this one will be plus 20. 0 plus 20 is 20 times a half. This is going to be 10 square units. 10 square units as the answer to that particular part. Let us look at part B, Roman 2, sorry, the midpoints. They want to use the mid-ordinate rule with 5 strips. Now to get the mid-ordinate, it's now going to be a bit simpler. We are going to have the values for x. Let's have the values for x there and the midpoint. So I'm just going to pick the midpoints. From 0 to 1, we have the midpoint of 0.5. From 1 to 2, we have 1.5. 2 to 3, we have 2.5. 3 to 4, we have 3.5. Then 4 to 5, we have 4.5. That's what we have. After getting that, we now need to work for the last part. And how are we going to have this one done? Let's have equation 1 minus equation 2. When you solve, or rather what we can do, I want a shorter way. Maybe let's just, what is the space? I have enough space. Let me just do, my equation 1 was x squared minus 5x plus 7. Let me substitute. First of all, let me rule so that my work doesn't get mixed up, and I want to maintain my work very clean so that anyone following through can literally see why STEM Smart Academy is ranked amongst the best online schools in Kenya and all over the world. We are going to see this in a few. We are going to see this in a few. So when x is 0.5, y will be given by 0.5 squared minus 5 into 0.5 plus 7. This gives you 4.75 here. When it is at 1.5, you just do replacement. This is 1.75. When it is at 2, oh my god, I've messed. Okay, let me see. So when it is at 2.5, so we have here a 2.5 squared minus 5 into 2.5 plus 7, that is 0.75. When it is at 3.5, that is 1.75. And when it is at 4.5, when it is at 4.5, that is 4.75. Then we have the second equation, y2, which is given by a half x squared minus 5 over 2x plus 7. So let us do still the same. That's like saying just 0.5 into 0.5 squared, 0.5 squared minus 5 over 2 is like saying 2.5 into 0.5, then plus 7. This gives you 5.875. 5.875. When it is 1.5, let us see. When it is 1.5 here, we are going to get it as 4.375. 4.375 at 2.5. At 2.5, what will be the corresponding value of y? 3.875. And at 3.5, what I'm doing here is just substituting very fast using my calculator. That's going to give me at 3.5, 4.375. 4.375. Then at 4.5, we are talking about at 4.5 now. We are talking about at 4.5, you get 5.875. Now let's have the region, which is equation 2 minus equation 1. So 5.875 minus 4.75, you're going to get this as 1.125. Then 4.375, you minus 1.75. This becomes 2.625. 2.625. 3.875 minus 0.75. This gives you 3.125. 3.125. Then 4.375 minus 1.75. This becomes 2.625. Then 5.875 minus 4.75. This is 1.125. We are having 1. We are having this as 1.125. Then after reaching that particular point, we are progressing well. What are we supposed to do? First of all, I have to get the h. Still, my h will be given by the last value of it That is still 5 minus 0 divided by 5 to give you a 1. Now, let's now apply the formula that area is given by h into y1 plus y2 plus y3 all the way to yn minus 1, that way. So this will be h, which is in this case 1 into 1.125 plus 2.625 added to 3.125 plus 2.625, then plus 1.125. When you add that, this gives you 10.625 square units. 10.625 square units. 10.625 square units. That marks the end of that question. Let's have a look now at the second last question of our discussion, which is question number 23. Triangle ABC is such that A, negative 6, negative 5, B, negative 5, negative 4, negative 5, and C, negative 4, negative 3. But A, triangle A prime, B prime, C prime is the image of triangle ABC under an enlargement center negative 3, negative 2, and scale factor negative 2. On the grid provided below, draw the triangles ABC and the image. So first of all, let us calibrate. So this will be 1, 2, 3, maybe 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, 1, 2, 3, 4, 5, maybe 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Then when we are here, A is, now let's draw the object. A is negative 6, negative 5, negative 6, negative 5, negative 6, negative 5 here. We have our A. B is negative 4, negative 5, negative 4, negative 5. That's our B. C, negative 4, negative 3, negative 4, negative 3. This is our C. Let us join the points to form the triangle needed. These are the points being joined to give us the needed triangle. We are joining to get the needed triangle. So that is the object. Let's get the image. The image, we are still looking at it. But they are said it's an enlargement center negative 3, negative 2. Negative 3, negative 2, it's at this particular point. But the scale factor is negative 2. When the scale factor is negative, you have to realize that the object and the image will lie on the opposite sides of the center of enlargement. And because it is negative 2, now that is going to become very, very simple. And I want you to agree with me on how we are going to progress. So if that is the case, then my C prime, I want you to be very, very keen. I want you to be very, very keen. My C prime is now going to be at let me use a red ink. My C prime will be at 1, 1, because it should be on the opposite side. So this is where my C prime is. What about 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, the other points. We are applying the same. So when you look at here, for instance, A is how many units? Let me see. 1, 2, 3. 1, 2, 3. So it will go the opposite side by 6. So this will be 1, 2, 3, 4, 5, 6 is here. So when you look at A prime well, A prime is at 3, 4. A prime is going to point 3, 3, 4. This particular, I'm using the counting technique. This part here will be now your A prime. Then when you apply the same, B prime is going to be at negative 1, 4. Negative 1, 4. This will be your B prime. Then now join A prime to B prime to C prime back to A prime. Let us do the joining together. We are applying the same in this particular question. Follow keenly. Don't forget to subscribe, like and share the video with your other friends. Follow along keenly. Follow along keenly. So we have to follow along keenly. That is it. That is how you draw the A prime, B prime, and the C prime. Part B, triangle A double prime, B double prime, C double prime is the image of ABC under positive 90 degrees, rotation center 1, 1. First, let's locate center negative 1, negative 1. This is the center they are talking about. Now it is positive 90 degrees. That is rotation. If it is positive, then it is a rotation in the anti-clockwise direction. This one means anti-clockwise. Anti-clockwise. Could it have been negative? Then it could have been in the clockwise direction. So let us rotate it. So when you do the rotation, I want you to take note of this well. I want you to take very, very good note of this. So when you rotate, our A double prime will become negative 6, 3. Negative 6, 3. We have negative 6, 3. Let me use a green ink. Negative 6, 3 here. Negative 6, 3. That will be our A double prime. Our B double prime will be at negative 6, negative 1. Negative 6, negative 1 when you do the rotation well. Negative 6, negative 1. This will be our B double prime. Then our C double prime will be at negative 2, negative 1. Negative 2, negative 1. This will be our C double prime. Now we can join the points. We can now join these points well here. Look at how the triangle is getting transformed. We have it there. Then after that, what is the question saying? We are done with the drawing. We have the 2 marks. Part C, triangle A triple prime, B triple prime, C triple prime is the image of A double prime, B double prime, C double prime under the reflection in the line y is equal to x plus 1. Y is equal to x plus 1. So first of all, draw the triangle A triple prime, B triple prime, C triple prime. Because it's a reflection, let's get this mirror line. Y is equal to x plus 1. I'm going to have a table over here. I'll have your table. I'm going to have a table. I'm going to have a mini table here of x, y values. When x is 0, y is 1. When y is 0, x is negative 1. When x is 1, y will be 2. That will be sufficient to draw. So let's draw that line. We have 0, 1. Let's plot the point 0, 1. 0, 1 is here. Negative 1, 0. Negative 1, 0 is here. Then 1, 2. 1, 2 is here. So you can see the path along which the mirror line is lying. Let us first draw that mirror line because it's very, very important. Let's draw the mirror line. We are now drawing the mirror line. This is the mirror line, ladies and gentlemen. This is what we call the mirror line for this particular equation. Let me draw my mirror line, and it must be a straight line. That is the mirror line, which I can label here. I can label this mirror line as y being equivalent to x plus 1. Now, it is the double primed image that is getting reflected, and you know the rules of reflection. I'm going to use the counting technique. Let me see the pen I might use. I just again use, I can still just use, let me use this one here. So I want to reflect a double prime. So I'll move 1, 2, 3, 4, 5, 6, 7, 8 up to the mirror line. Then I'll move 8 downward. 1, 2, I've said 1, 2, 3, 4, 5, 6, 7, 8. This particular point will be my A triple prime. My A triple prime. Then looking at B double prime, I want to get the triple prime. So I'll move down 1, 2, 3, 4. Then 1, 2, 3, 4. This particular point will be the B triple prime. Then looking at C double prime is exactly on the mirror line. Therefore, it will not undergo any change. So that will just become again my C triple prime. Then we are now going to join the points. Look at what is getting formed when we join. Look at the beauty of mathematics being illustrated here. The beauty of mathematics, well illustrated at that particular point, that way. Then after that, we are done with that drawing. So the question says, state the pair of triangles that are directly congruent. Anything that has undergone a rotation, and an enlargement will be under direct congruency. So let us see, do we have any triangles that have undergone a rotation? From the statement themselves, no need even to focus on the diagrams. We are being told that these ones were under an enlargement. This is the image of this under an enlargement. And remember, I've said any enlargement is a direct congruency. Any enlargement is a direct congruency. So first we are going to state ABC and A prime, B prime, C prime. Because those ones were under some direct enlargement. Again, we can see the double prime is the image of the single prime by a rotation. So that is also direct congruency. So that means A prime, B prime, C prime, and A double prime, B double prime, C double prime is directly congruent because it was a rotation. Then now let's look at part C, opposite congruency. Anything that has undergone a reflection is under opposite congruency. So do we have anything that has been mapped by a reflection? The triple prime is the image of the double prime by this reflection. That means the two are oppositely congruent. That means the double prime image and the triple prime image. So here I'll say the A double prime, B double prime, C double prime, and the triple prime image, that is A triple prime, B triple prime, and C triple prime. That is how you have to link the two. Let us have a look at now the last question of our discussion, ladies and gentlemen, that the displacement s meters of a moving particle from point O after t seconds is given by s is equal to t cubed minus 5t squared plus 8t plus 7. Part A of the question, find its displacement when t is equal to 3. So when t is equal to 3, to get the value of s, we are just simply going to substitute. This will be 3 cubed minus 5 into 3 squared plus 8 into 3 plus 7. This will be 27 minus 45 plus 24 plus 7, which is going to give you 13 meters. As simple as that. Part B, the velocity of the particle when t is equal to a. One thing I want learners to understand, we do have displacement, velocity, and acceleration. When I move from displacement to velocity or from velocity to acceleration, I'm going to do what is called to differentiate. But when I'm moving from acceleration back to velocity or from velocity back to displacement, I'm going to do what is called integrate, or rather integration. This is very important. So I have the equation for displacement. I want to get first the velocity. So from displacement to velocity, I have to differentiate. So V will be obtained by taking ds over dt. I'll differentiate displacement with respect to time. When you differentiate, what are some of the things that you need to understand? The power drops down, then you raise the power by 1 to get the new power. So this will become 3t squared minus 10t plus 8. Then the constant disappears. So after that, now you have to say when t now is equivalent to 4, v will be given by, you substitute t into the v equation, 3 into 4 squared minus 10 into 4 plus 8. So this will be 16 squared times 3, that will be 48. We are going to have it as 48 minus 40 plus 8. 48 minus 40 is 8 plus 8. This gives you 16. Because it's velocity, so it's 16 meters per second. 16 meters per second to that particular question. Roman 2, the value of t when the particle is momentarily at rest. You have to understand that at rest, ds dt, in other words, velocity is normally equivalent to 0, because at rest there is no speed. So at rest v is normally equivalent to 0. So let's take the equation for velocity, which we found as v. Remember, we had v being equivalent to 3t squared minus minus 10t, sorry. This should be minus 10t. We have here minus 10t plus 8 and equate this to 0. So I'm going to look for the sum and the product. I'm going to look for the sum, two numbers whose sum is negative 10 and whose product will be 3 times 8, 24. So the two numbers, the sum is 10 and the product is, the sum is negative 10 and the product is 24, is negative 4 and negative 6. So this will now mean that we have 3t squared minus 4t minus 6t plus 8 equal to 0. So this will be t into 3t minus 4 minus 2 into 3t minus 4. That way, equal to 0. Upon reaching there, those that are outside the bracket, we put them into one bracket. We are now going to have t minus 2, then 3t minus 4 being equivalent to 0. When you reach here, the first case we're going to have t minus 2 is equal to 0, meaning the value of t is equals to 2. In the next case, we can have 3t minus 4 is equal to 0, meaning that 3t here will be equivalent to 4, and t will be equivalent to 4 over 3. That 4 over 3 is written as 1 and a third. So when they say determine the values of t when the particle is momentarily at rest, we are going to say t is equal to 1 and a third seconds, or 2 seconds. That is how you get the values of t for that particular question. Let us make progress to question number Roman 3. The time when the particle is moving at minimum velocity. When is this particle moving at minimum velocity? At minimum velocity, what I want you to understand is the term minimum velocity. At v minimum, acceleration is normally equivalent to 0. Very, very important point. That at minimum velocity, acceleration is normally equivalent to 0. So first of all, let's get the equation for acceleration. Remember, when you have a velocity, you can get acceleration, because acceleration is given by differentiating velocity with respect to time. So let's differentiate the equation for velocity. So when you differentiate, this will be 6t squared, no, it will be now 6t, because the power will get reduced by 1 to become 2 minus 1 is 1. So this will be 6t minus 10. 6t minus 10. So the equation for acceleration now, ladies and gentlemen, we are having the equation for acceleration being equal to 6t minus 10. But for minimum velocity, then this acceleration should be equal to 0. So that means when I take 6t minus 10, it should be equivalent to 0. This means 6t will be equivalent to 10, and t will be equivalent to 10 over 6, which can be simplified to t being equal to 5 over 3. But do we leave it at that particular point? No. This is an improper fraction. You have to make your answer to be equal to t being equal to 1/2 over 3 seconds. So velocity is minimum when t is 1 2/3 seconds. The velocity is minimum when t is 1 2/3 seconds. That is how you will have responded to this wonderful question paper, and that marks the end of section B of this paper. If you feel you've gained something, don't forget to share the paper to your other friends, invite them, subscribe to my channel, then see you in our next discussion. Goodbye.